Hi, in this lesson we want to talk about the hyperbolic function. Now the hyperbolic function or the hyperbola is normally represented in this format, but sometimes it may not have all the p's and the q's just like our previous functions, where they can exist in a much simpler nature such as a over q, right? So the p and q are generally just shifts. The p is normally used to denote horizontal shifts. Q is normally used to denote vertical shifts. Now the main question here is, what does the A represent? So the A represent in which quadrants we draw our functions in. Here we are in the first and in the third quadrant. This is when our A is greater than 0. But when our A is negative, or when it's less than 0, then we have our function in the second and in the fourth quadrant. Generally, the hyperbolic function can get a bit complicated, but not if you practice it often. So the main questions or the main underlying feature that makes it a bit difficult is the fact that it has two asymptotes, and generally they tend to ask questions about the asymptotes of the hyperbola. So in this case, what I've drawn here are both examples of either y is equal to, so y is equal to a over x. This can be negative or positive, this one being positive, this one being negative 1 over x. When we introduce shifts into the picture, then we have something like this. So let's say we move it 2 units to the right. That means we're gonna have our asymptote at this point here, and we shift it 1 unit down. That means we're gonna have our asymptote over here. So 2 units to the right and 1 unit down. That means this will be 2s2 minus 1. So these are the coordinates of, or this is the coordinate where our asymptotes meet. Now remember from the previous video that an asymptote is a line that your graph will not cross or touch. And in this case, this really affects our function and the way that we define it. And we're going to speak more about defining our functions or describing the properties of our functions with respect to the domain and the range in the videos to come. But for this video, we just want to take a look at an overview of the hyperbolic function and the questions that they tend to ask without getting into the properties of it. So here I can draw the function in my third quadrant and in my first quadrant. Notice how in the simpler drawings we did not have any asymptotes. We did not have any intercepts. This is because our axes are actually the asymptotes themselves, which means our graph will not cross the y asymptote, it will not cross the x asymptote. Therefore, we won't have any or intercepts. Then the other thing that I want to talk about is the axis of symmetry. Now our function has two primary axes of symmetry, unlike previous functions such as the parabola, which only has one axis of symmetry, which is along the turning point of the function. This one will have an axis of symmetry that is negative. Let's make that green. It will have an axis of symmetry that is negative, and it will also have an axis of symmetry that is positive. And you can be asked to get both. One good thing about it is that the axis of symmetry will always have a gradient that is either -1 or a gradient that is +1. All you need is the points where the asymptotes intersect, and you are able to then use the gradient of either 1 or -1, depending on the one the question is required. requiring. But this is about it for hyperbolic functions. We're gonna discuss the domain and range in the videos to come.